Hey there, I'm Joe Carter. If you've ever popped the hood and thought, where do I even start? You're in good company. Around here, we take the mystery out of car repair, one fix at a time. Whether you're a beginner or just looking to sharpen your skills, there's something here for you. Don't forget to like the video and subscribe if you're into learning without the headaches. All right, that's enough from me. Let's get into it.
The principle of operation of the turbocharger allows you to significantly increase the power of automobile engines. For a better understanding of the operation of the system, let us consider in detail the device of the turbine and the overpressure valve. Wastegate, from the English word wastegate. Depending on the principle of operation, the valve is called bypass, or blow-off. Wastegate design. The device of a gas turbocharger, bearing housing assembly, turbine cartridge. Turbine wheel hot end. Bypass valve. Turbine housing, blower hot part. All supply ducts to the rotor shaft plane bearings. Rotor shaft. Sealing washers. Compressor wheel. Compressor housing, cold part of the blower. Bypass valve actuator. It is turbochargers of this type that are most often installed on diesel and gasoline engines. The device of the simplest gas turbine is characterized by the absence of a bypass valve. Some gas-type turbochargers have channels for the circulation of antifreeze. This eliminates the need to install a turbo timer to prevent oil burning due to high temperatures. The rotor shaft, together with the turbine and compressor wheels, rotates at a very high speed as the exhaust gases flow around the rotor. For normal operation of the shaft, the design provides support bearings, which are most often plain bearings. Designs with conventional ball bearings reduce friction losses. However, they have a shorter service life, so they are mainly installed on cars for motorsport races. The main purpose of support bearings is to create support points for rotation in the central part of the housing. Note that one of the videos shows the design of a turbocharger, in which separate support bearings are installed on the rotor shaft. In the second video, the device is described on a model in which the thrust bearing is in the form of a sleeve fixed by a bolt. Thrust bearings, which are designed to prevent axial play of the turbine shaft. Thrust and thrust bearings operate on an oil wedge. The ingress of engine oil is undesirable in both the hot and cold parts of the turbocharger. To prevent this, O-rings are fitted on the rotor shaft. They are not directly lubricated, as is the case with thrust and radial bearings. Prevention of accelerated wear of the rubbing surfaces is achieved by operating on oil mist, fine particles of engine oil that are splashed as the rotor shaft rotates. Importance and operation of the lubrication system. This is primarily due to the need for quality lubrication of the turbine rotor shaft bearings. Oil to the bearings is supplied under high pressure through special channels in the cartridge, respectively. In the housing there is a special connection through which the oil comes from the general lubrication system of the engine. The discovery of the oil wedge effect in its time gave a huge impetus to the practical application of hydrodynamic principles of lubrication. The essence of the effect is to create an oil film between the rubbing surfaces during operation, almost completely eliminating friction between the moving surfaces. It is important that a pressure is established between the rubbing surfaces to keep the parts rotating at a relative distance from each other. This is accomplished in two ways: high pressure in the lubrication system, precise fitting of the rubbing pairs. This means that there must be exactly enough clearance between the shaft and the plane bearings to create a reliable oil wedge. This is why a small amount of axial and radial play of the rotor shaft is vital for the life of the turbine. The main cause of failure consequences of a collapsed turbine actuator. Consequently, at low speeds, a small turbine will give greater power gains, whereas at high speeds, the small hot section cross-sectional area will result in significant exhaust gas opposition. Also, each turbine has a pressure limit, exceeding which will result in airflow, straying from the blades and loss of performance. On how the turbine actuator allows you to avoid pomp in the intake system at the moment of abrupt throttle closure, to increase the degree of compromise between performance at high and low speeds. we recommend you to read in the article Turbocharging in Theory and in Practice. Our goal is to consider the device of overpressure valves of different types. Bypass the design of two types is used, closed cycle. Through a special channel, the overpressure is supplied to the hot part of the turbine, which reduces the inertial losses for spinning of the turbine wheel during subsequent acceleration. The system consists of a valve, air lines and a turbine actuator regulator that moves the valve stem. The regulator has a vacuum control system and is coupled to the intake manifold via a diaphragm. When a certain inlet pressure is built up, the diaphragm bends out, overcoming the force of the return spring, and opens the bypass valve through the linkage system. Open cycle. The principal difference is that when the valve opens, the air flow is offensive to the turbine wheel and is directed directly into the exhaust pipe. Blow off. In conclusion, the innovative concept of turbine design on the fingers showcases the remarkable intersection of engineering and human capability. By harnessing the principles of aerodynamics and miniaturization, we can create efficient, portable energy solutions that empower individuals in their daily lives. As we continue to explore and refine these designs, the potential for sustainable energy generation becomes increasingly promising. Thank you for joining us on this journey into the future of turbine technology.